In Lesson 61, we'll learn about subsets and learn about what the subsets of real numbers are. Now, if you remember back in Lesson 56, we learned about sets, and we learned about some special symbols that are used when we're talking about a set. For example, we could say that 6 is a member of set A. We could also say 6 is a member of set B. But that symbol there between the 6 and the A, basically we can think of that as saying is a member of. 6 is a member of set A. Now a subset, that's basically a set that has all of the numbers in another set. The way we describe that is with a symbol that looks similar. It just doesn't have that middle line segment in it. So we could say that B is a subset of A, and we just write just like this. And that does kind of look like a C in there, so you have to kind of really extend these lines out so that it doesn't look like you're trying to draw a C. But B is a subset of A. That's what that statement is describing. All of the members of set B are members of set A. That's why we can call it a subset. That's how a subset is defined. This is not a true statement, though. A is not a subset of B because all the members of A are not members of B as well. So we put a slash through this to say not. A is not a subset of B. Now look at set C that I've drawn up there. Set C is a subset of A. We can say C is a subset of A. The reason for that, by definition, a subset, all of its members are also members of another set. So that's true. All the members of C are also members of A. So when they have all the same numbers, C would be a subset of A, and the reverse would be true as well. A is a subset of C. Now we can apply what we know about subsets to the different types of sets of numbers, such as real numbers and whole numbers and counting numbers, things like that. Now if you think about counting numbers, remember counting numbers, those start with 1, 2, 3, 4. Whole numbers, those start with 0, 1, 2, 3, 4. So we could say that counting numbers, I'll just say CN for counting numbers, those are a subset of the whole numbers. I'll say WN for the whole numbers. Whole numbers, those would be a subset of the integers, because remember integers are like whole numbers, but they include negative numbers as well. So we could just say that those are a subset of the integers. Integers, those could be considered a subset of something called the rational numbers. I'll just say RA for rational numbers. Rational numbers, remember rational, when you hear that word, that prefix there is ratio or fraction. Rational numbers are numbers that can be expressed as a fraction. So that would include all of the integers as well. And then those are a subset of the real numbers. So we can just say R for real. So counting numbers are a subset of whole numbers, which are a subset of integers, which are a subset of rational numbers, which are a subset of the real numbers. Now there are also irrational numbers. We'll just say IR for them. And those are numbers that cannot be expressed as a fraction. For example, a lot of the square root of a number, like square root of 2, square root of 5, square root of 7, numbers like that, those cannot be expressed as a fraction. So we would say that the irrational numbers are another subset of real numbers. Now if that's a little bit confusing, there's another way we can describe these that might be a little bit easier to understand. And let's just make a big box. And the reason we're doing this is just so you can see how these different sets compare. That's just an important skill in algebra and in life, is to be able to organize a certain set of information and see what its comparison is to other members. So let's just take this big box and we'll call within the big box is the real numbers, all the real numbers. On the left side, we'll call these the irrational numbers, so we'll just say IR. And then on the right, we'll consider all of these the rational numbers. And then we said that integers, those are a subset of the rational numbers. So let's make another smaller box here. And we'll say I for integers. Now within that, we have our whole numbers. So we'll say W for whole numbers, or WN like we did before. And then within that, we have our counting numbers. So we'll put another box inside that and say CN. So counting numbers, those are within the whole numbers, within the integers, which are within the rational numbers. And then you also have your irrational numbers. All of those are subsets of the real numbers. Well, now that we understand subsets, let's do a few practice problems. Look at these practice problems. What I want you to do is just tell me if those statements are true or false. And the C, B, and B there, those are the sets that we have over to the left. So in practice problem A, what I want to know, is that a true statement? C is a subset of the irrational numbers. Well, irrational numbers, those are numbers that cannot be written in a fraction form. And in set C, all of those numbers could be written as a fraction. You could write them all over 1. And so that would be a false statement. So I'll just say F for false. Now practice problem B. B is a subset of the whole numbers. Is that a true or false statement? Well, look at B, 0, 6, and 9. The whole numbers, remember, those start with 0. They're counting numbers starting with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, B would be a subset of the whole numbers. So we would say true for that statement. And then practice problem C. B is a subset of the counting numbers, true or false? Well, you just have to think, what are the counting numbers? Well, those start with 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. B has a 0 in there. 0 is not a member of the counting numbers, so we would not say that B is a subset of the counting numbers. And so that is false. Make sure you understand the notation used to describe subsets, and then also that you understand the organization of the major subsets of real numbers. Okay, well that's all for lesson 61.